In this video, we're going to be looking at a displacement time graph. So on a straight line lie the points A, B, C in that order. So let's draw ourselves a diagram so you can just visualize where these points are. So here is my line. And we've got A, B and C in that order. The distance from A to B is 2 meters and the distance from B to C is 4 meters. So here is point A. Then you've got point B, and this is 2 meters in distance. And then from B to C is 4 meters. So there's point C, and this is 4 meters. A person starts at point B. So they start at point B. They travel to A at a constant speed for 2 seconds. They wait at A for 3 seconds. Then they travel to C in 5 seconds. So they're going from point B to point A, they wait, and then they travel to point C. Draw a displacement time graph of the person's motion from B. So let's draw ourselves some axes so we can visualize what's going on. Now, because the motion initially starts moving to the left, okay, we're going to take to the left of B to be a negative direction and to the right of B to be positive, okay? So that means because it goes negative, I'm going to have a bit that goes below the time axis, as we will see. So here we have displacement, which is in meters, and time, which is in seconds. So it starts off, a person starts at point B, so they start off with 0 displacement. They then travel to A at a constant speed for 2 seconds. So they travel 2 meters to the left in 2 seconds. Now, just so I know I'm not going to go over my axes, how much time have we got in total? We've got 2, 5, 10. So this has got to be up to about 10 seconds. Okay, I think I can work with that. So we're going to go 2 seconds and we're going to travel 2 meters in the negative direction. So 2 meters in the negative direction for 2 seconds. And so the graph starts by doing this. Okay, so you are 2 meters, so minus 2, that should be, minus 2 meters in 2 seconds. They wait at A for 3 seconds. So for 3 seconds, we're going to wait at A. So we're remaining at minus 2 meters for 3 seconds. Okay, and then they then travel to C in 5 seconds. So in 5 seconds, so let's put the 10-second mark here. Okay, in 5 seconds, they go from A to C. So you travel 2 meters back up to get to B. So in going back up to the line, you're going back to B, and then another 4 meters to get to C. So 4 meters, it's got to be somewhere around about here. So something like this. So this is my displacement time graph. Now it looks a bit strange, doesn't it? Okay, it looks a bit strange, but the idea here is that you're starting at B, you've gone 2 meters to the left, you stay 2 meters to the left, and then you go 6 meters to the right. So that's a total of 6 meters, from minus 2 up to 4. Okay, so a total of 6 meters been travelled. And you've also got the fact that within those next seconds there, you will have got back to point B. So once you're on that line, your displacement from B is 0. So you have returned to B at that point. Okay? So there are a few questions that could be asked here. So you could be asked things like, what is the velocity of a particle at a particular time? So we would need to work out the gradient of part of this line. So maybe you want to work out what's the gradient, what's the speed of the particle at when time is 1. So it is whatever that gradient is, which would be -1, wouldn't it? Okay, because it's 2 divided by 2. And you're going in a negative direction. So you could have here, that is a speed of -1 meters per second. Or a velocity, rather, of -1 meters per second. Got to get the language right. Okay? Then you've got a velocity of 0 meters per second. And then you've got this velocity here, which is 6 meters divided by 5. So 6 over 5 is 1.2 meters per second. So a positive 1.2 meters per second for that section. Okay? So you could get asked questions about the velocity at different stages, or the speed at different stages. Okay, so we're going to take a look at that type of problem in the next video.